So in our studies thus far, we have been looking at the polio virus, and we have looked at the history of polio being totally eradicated or totally gone from society because of the effective use and development of a vaccine. Today we're going to talk, or in this lesson, we're going to talk exactly how does a vaccine work against viruses, and this can also be used for future viruses that we're going to talk about in class. So our immune system, and this is a little review about the immune system. The immune system protects our body, and it protects our body from pathogens. Pathogens that can cause diseases. Now, a pathogen that we talked about in the polio situation is the polio virus. So we have said that a vaccine is, or it is said rather, that a vaccine is a pathogen imposer. It looks like a certain bacteria or virus to the immune system, but doesn't make our body sick. So exactly what is a vaccine? I'm going to write a little definition here to summarize that. A vaccine is a weakened or, let me just take this off, weakened or dead form of the virus or bacteria that does not make us sick. Good. So a vaccine is a weakened or dead form of the virus or bacteria that does not make us sick. And that is the most important definition of what a vaccine is. So how is the weakened form of a bacteria or a virus not makes us sick? We're going to look at that. So pathogens, our body recognizes pathogens because pathogens are covered with antigens. And that triggers a specific immune response. From previous lessons, you would have known as soon as the body detects an antigen, it starts releasing antibodies, right? And the B cell will release antibodies so that it detects that, hey, this is a pathogen. This is something that does not belong to our body. So pathogens are detected by the antibodies. And how does the antibody know that this is a pathogen? Because all pathogens are covered with antigens. So let's look at a response to a vaccine. Now, this is a vaccine that is delivered to our cell. And as you can see, this is our pathogen. And our pathogen on its surface have antigen. All right? So this is our pathogen, and that is the antigen that is found on the surface. Just give me a second here. Good. So now we have our helper T cell. Our helper T cell is going to recognize that antigen, and our naive B cell, or there, our plasma B cell is triggered, and then we make antibodies. Now for our class, I really don't want you to worry about this phase. I just want you to know that once the antigen or the antigen is detected by the helper cell, it releases antibodies. Now these antibodies are specific shape. Alright, so let's see what happens next. Then we have our vaccine antigen combination or combining with the antibodies that are produced by our helper T cell. Now, if we look at an alternative pathway, is that now that will activate our killer T cell. And I'm going to take out this here again. We don't need that. So our T cell now will be activated, and then the infected cell will be damaged. So just as a quick review of what is happening here, just to summarize, is that the vaccine have the weakened form of the pathogen being injected to us. And how do our body know that that's a pathogen? Because on the surface of pathogens are antigen. And our helper T cell will respond. Our helper T cell will produce antibodies. Our antibodies will go and bind to the antigen of the parasite, of the virus or bacterial pathogen. And then that will activate a killer T cell. The killer T cell will go and get rid of the microorganism. So another piece of the puzzle that I did not mention the last time we were talking about white blood cell is that once the killer T cell kills the infected cells that are infected by the virus or pathogen, it makes memory cells. And this is the key of vaccination. Now, whenever you take a vaccine, it will remember the virus. And how does it remember the virus or the bacteria? Because of that specific shape of antigen that is present on the surface. So now let's look at what happens when the pathogen comes in. And this is not administered by a vaccine. This time, the stronger strain is coming in with the same antigen that is present. Your memory cell shows up in response, and your memory cell will then release the antibodies. A very quick type of scenario, and then the antibodies will bind to the pathogen antigen, and then the killer T cell will kill the infected cell. This is a much quicker process. So instead of going through sickness or a disease and all of these things, the memory cell is now activated instead, who now takes control and get rid of the infected cells.